12,800 years ago, humans woke up to what seemed like a normal day. But by sunset, that world was ending. Not from war and not from plague, but from something that came from space. Something that hit Earth so hard, it reset human civilization and killed 90% of all large animals on the planet. And we have the physical proof. This event is called the Younger Dryas impact, and for decades, mainstream science denied it happened. They said the evidence was coincidental or misinterpreted, but in the last 20 years, the proof has become so overwhelming that even the most hardened skeptics are starting to admit something catastrophic occurred 12,800 years ago that fundamentally changed the trajectory of human history. Here's what we know happened based on the evidence. A comet or multiple comet fragments entered Earth's atmosphere, traveling at tens of thousands of miles per hour, and exploded over North America and possibly other locations around the globe. The impact released energy equivalent to millions of nuclear bombs detonating simultaneously. The shock wave flattened forests across thousands of square miles. The heat was so intense it melted rock and sand into glass, and the debris thrown into the atmosphere blocked out the sun for months or possibly years. The immediate effects were devastating, with massive wildfires consuming entire continents as burning debris rained down from the sky. But the long-term effects turned out to be even worse because the debris in the atmosphere caused global temperatures to plummet by as much as 15 degrees Celsius in some regions within just a few weeks. And this temperature crash lasted for over 1,000 years, plunging Earth back into Ice Age conditions just when the planet was finally warming up and coming out of the last glacial period. The Younger Dryas impact explains mysteries that conventional archaeology simply can't answer. Like, why did 35 species of megafauna suddenly go extinct in North America around the same time? Why do cultures all over the world have flood myths that all seem to date to roughly the same period? Why is there a distinct boundary layer in soil across the entire planet showing evidence of cosmic impact? And why did human population crash so dramatically that genetic studies show a severe bottleneck around 12,000 years ago? For years, scientists dismissed this theory because they couldn't find a crater. But in 2018, researchers discovered a massive impact crater under the Greenland ice sheet called Hiawatha crater that dates to exactly the right time period. And suddenly the theory moved from the fringes into mainstream acceptance. What we're looking at is the most significant catastrophe to hit human civilization in recorded memory. An event so devastating that it destroyed whatever advanced societies existed before it and forced the survivors to start over essentially from scratch. And the evidence is written in the geological record in a layer of debris that circles the entire planet, marking the exact moment civilization ended. The question isn't whether this happened because the evidence proves it did. The question is whether it can happen again. There's a layer of death circling the entire planet, a black scar in the soil marking the exact moment civilization ended, and you can dig it up yourself right now at hundreds of locations around the world and hold 12,000-year-old evidence of apocalypse in your hands. Evidence that only comes from one thing: cosmic impact. If you dig into the ground across North America and Europe and Asia at the depth corresponding to 12,800 years ago, you'll find this thin band of black sediment filled with materials that shouldn't exist in normal geological layers. And geologists call it the black mat, one of the most distinctive features in the stratigraphic record, appearing suddenly in soil cores and excavations dated to exactly the moment when everything changed. What makes this layer so significant isn't just that it exists, but what it contains, because the black mat has high concentrations of charcoal indicating massive wildfires burning simultaneously across entire continents. And we're not talking about normal forest fires from lightning strikes. We're talking about conflagrations on a continental scale that would require an external ignition source like superheated debris falling from the sky and igniting everything it touched. But here's where it gets really crazy. The black mat contains microscopic diamonds called nanodiamonds that only form under conditions of extreme pressure and temperature. The kind of pressure and temperature you get from cosmic impacts or nuclear explosions. And these nanodiamonds are scattered throughout the layer, in concentrations far higher than you find in normal sediment. And their presence is essentially a smoking gun for extraterrestrial impact. The layer also contains spherules, which are these tiny spheres of melted rock and metal that formed when material was superheated to thousands of degrees and then rapidly cooled as it fell back to Earth. And these spherules show magnetic properties and chemical signatures that are consistent with cosmic origin, and they're found mixed together with the nanodiamonds and the charcoal in this distinct boundary layer, marking 12,800 years ago. Now, I know this might sound like a geology lecture, but stay with me, because these aren't just academic terms. These are physical proof of the day the world burned. And what really convinced many skeptical scientists to take this seriously was the discovery of a platinum anomaly in the black mat, because platinum is extremely rare in Earth's crust, but relatively common in asteroids and comets. And when you measure platinum concentrations across this boundary layer, you find them jumping by over 300% compared to the sediment above and below it. The only known natural process that can create this combination of evidence is cosmic impact, because you need the extreme temperatures to create the nanodiamonds and spherules. You need the widespread fires to create the global charcoal layer, and you need extraterrestrial material to explain the platinum spike. And all of this evidence converges at exactly 12,800 years ago in a layer that literally circles the planet. The black mat marks a boundary between two completely different worlds. Below it, you find evidence of megafauna and human activity in a warmer climate. But above it, you find mass extinction and climate collapse and a drastically reduced human population. Harvard scientists were analyzing ice cores from Greenland when they found something that made them stop and double-check their equipment: platinum levels spiking to 100 times normal concentration at exactly 12,800 years ago. And platinum doesn't just appear in ice for no reason. It comes from space. And this spike marks the exact day the world ended. Platinum is what scientists call a siderophile element, meaning it bonds with iron and sinks to Earth's core during planetary formation. So the amount of platinum in Earth's crust is extremely low, typically measured in parts per billion. But asteroids and comets that never went through planetary differentiation have much higher platinum concentrations, which means that when you find elevated platinum in geological layers, you're looking at a marker for cosmic material that reached Earth's surface. The younger Dryas platinum anomaly isn't subtle. We're not talking about a small increase that could be explained by natural variation. In some locations, the platinum concentration increases by factors of 100 to 300 times normal levels. And this spike appears in ice cores from Greenland and sediment, cores from North America and Europe, and even in lake sediments from South America, suggesting that whatever deposited this platinum did so globally and not just in one localized impact zone. What makes this evidence particularly strong is that platinum isn't the only element showing anomalies at this boundary. Iridium, which is another rare element that's more common in space rocks, also shows elevated concentrations at the exact same point in time. And when you find both platinum and iridium spiking together at the same moment across multiple locations around the world, you're building a very strong case for extraterrestrial impact, because there's simply no terrestrial geological process that would create this pattern. The timing of the platinum spike is impossibly precise, occurring at exactly 12,800 years before present, with an uncertainty of only plus or minus 50 years. And this date corresponds perfectly with the beginning of the Younger Dryas coal period, and with the boundary layer containing the nanodiamonds and spherules we talked about earlier. So everything lines up to point at the same catastrophic moment, suggesting a single event rather than multiple coincidental processes. Some skeptics initially argued that maybe the platinum came from volcanic eruptions, because volcanoes can bring up material from deep in Earth's mantle. But volcanic platinum deposits show different isotope ratios and different associated elements than what we see in the Younger Dryas layer. And more importantly, there's no evidence of any volcano erupting at exactly 12,800 years ago, with enough force to deposit platinum globally across multiple continents and in the ice sheets. The platinum spike also appears in marine sediments from the Pacific and Atlantic Oceans, with researchers finding elevated platinum concentrations in ocean floor cores at depths corresponding to 12,800 years ago. And this makes perfect sense if you have an impact or air burst over North America, because the debris would be carried by atmospheric winds and eventually settle in oceans worldwide. What's really telling is that the same platinum and iridium signature appears at other major impact events in Earth's history, most famously at the Cretaceous-Paleogene boundary 66 million years ago when the dinosaurs went extinct. And seeing the same signature at 12,800 years ago tells us we're looking at the same type of catastrophic event, just much more recent. And that means people alive at that time looked up and watched the sky catch fire. In Siberia, they keep finding mammoths frozen so quickly that their flesh is still edible after 12,000 years. And I'm not talking about mammoths that slowly froze to death in a blizzard. I'm talking about mammoths that were literally eating lunch when they died, frozen so rapidly that there are still flowers in their stomachs that never finish digesting. And that kind of instant freezing requires something catastrophic on a scale that's hard to comprehend. The most famous example is the Berezovka mammoth discovered in 1901 in Siberia. And when scientists excavated this mammoth, they found it in a standing position with its mouth still full of vegetation that it was chewing when it died. And in its stomach, they found undigested grasses and buttercups and other plants that only grow in temperate climates and not in the frozen tundra where the mammoth was found, suggesting that the climate changed catastrophically fast between the moment it was eating and the moment it froze completely solid. For a mammoth to freeze solid before the food in its mouth could be swallowed or the contents of its stomach could be digested, the temperature would have to drop to well below freezing almost instantaneously. And we're talking about a temperature crash so severe and so rapid that a 10-ton animal didn't have time to finish chewing its food. And that doesn't happen from normal weather patterns or even from volcanic winter. You need something that changes atmospheric conditions globally and immediately. What makes this evidence even more compelling is that it's not just one mammoth, because all across Siberia and Alaska and northern Canada, they keep finding frozen mammoths and other megafauna in similar conditions. Some are found standing up as if they were walking when they froze. Others have undigested food in their digestive systems, showing they were actively feeding right before death. And many show signs of sudden violent death, rather than the slow starvation or gradual freezing you'd expect from normal climate change. The standard explanation from mainstream science is that these animals died in normal climate conditions and then froze later as glaciers advanced over their remains. But that explanation doesn't work when you look at the fresh food in their stomachs or the fact that their flesh hasn't decomposed at all. Because if there was any delay between death and freezing, bacteria and scavengers would have destroyed the soft tissue long before ice could preserve it. But instead, these mammoths are so well preserved that dogs have literally eaten their meat 12,000 years after they died. The vegetation found in the mammoth stomachs is also telling us something critical about the pre-impact climate, because the plants they were eating don't grow in tundra environments. They grow in temperate grasslands with mild climates, which suggests that before the impact, Siberia and Alaska weren't the frozen wastelands they are today, but were actually productive grasslands that could support massive populations of megafauna. And then something happened that changed everything almost overnight. Picture what it must have been like for these animals in those final moments. You're a mammoth peacefully grazing in a temperate grassland, and suddenly the sky explodes with fireballs. The temperature drops by tens of degrees in just minutes. Your breath starts freezing in the air, and within hours you're encased in ice that won't melt for thousands of years. And this wasn't happening to just a few unlucky individuals. This was happening across an entire hemisphere simultaneously. The frozen mammoths are physical evidence of a climate catastrophe so severe and so rapid that it trapped animals in mid-activity. 12,800 years ago, North America was like the Serengeti on steroids. You had giant ground sloths the size of elephants and saber-toothed cats and dire wolves and camels and horses and mammoths and mastodons. 35 different species of megafauna weighing over 100 pounds. And within just a few hundred years, 90% of them were extinct. And that's not how normal evolution works. That's how catastrophe works. This extinction event is called the Quaternary extinction, and it's one of the most debated topics in paleontology because the timing and the selectivity of what died don't match any of the normal extinction patterns we see in the fossil record. Most mass extinctions in Earth's history affect all sizes of animals relatively equally, but this one specifically targeted large animals while smaller animals survived relatively unaffected. And that pattern suggests something very unusual about the extinction mechanism. The mainstream explanation for decades has been human overhunting. The idea that as humans spread across North America, they hunted the megafauna to extinction. But this theory has massive problems when you actually examine it closely, because first of all, you simply cannot hunt 35 different species to extinction across an entire continent in just a few hundred years, especially when human population was relatively small. And second, why would humans specifically hunt every single large species to complete extinction while leaving smaller animals alone? And third, humans had coexisted with many of these species for thousands of years in other parts of the world without causing extinction. So why did it suddenly happen at 12,800 years ago? What makes the younger Dryas impact theory much more convincing is that it explains both the incredible speed and the strange selectivity of the extinction, because large animals require much more food and much more stable habitats than small animals. So when you have a catastrophic climate change that destroys vegetation across entire continents and drops temperatures by 15 degrees Celsius, the big animals starve first because they simply can't adapt their enormous food requirements quickly enough. Meanwhile, small animals with lower caloric needs and much shorter reproduction cycles can survive on whatever scraps of food remain and rebuild their populations relatively quickly once conditions stabilize. The extinction also wasn't limited to North America. South America actually lost even more megafauna, including giant ground sloths and glyptodonts and massive armadillos and giant capybaras. Australia lost its megafauna around a similar time frame, though the dating is less precise. And Europe and Asia also saw significant extinctions, though not quite as severe as the Americas, suggesting that whatever caused this was a global phenomenon, but hit some regions harder than others, depending on their distance from the main impact zones. Paleontologists have found what they call mass death assemblages from this period, which are bone beds where hundreds or even thousands of animals died together in a very short time frame. And these aren't normal fossil deposits where animals gradually died and accumulated over thousands of years. These are catastrophic death events where entire herds perish simultaneously, and the condition of the bones shows evidence of rapid burial, suggesting they were quickly covered by sediment, possibly from massive flooding or debris flows triggered by the impact. The genetic evidence also strongly supports a catastrophic cause, because when scientists sequence DNA from surviving species, they find what's called a genetic bottleneck around 12,000 years ago, meaning the population of many species crashed so low that genetic diversity was severely reduced. And you can see this effect in modern animals where species that went through the younger Dryas show much less genetic diversity than you'd expect, indicating that their ancestors were reduced to very small populations that barely survived. And here's the thing that should really make you think. This wasn't a gradual decline over thousands of years. This was a population collapse that happened within just a few generations. Imagine waking up to a normal spring day with birds singing and flowers blooming. And then 1 week later, the temperature has dropped 15 degrees Celsius and stays there for over 1,000 years. That's not a cold snap. And that's not even a normal ice age. That's a climate switch so rapid and so severe that it shouldn't be possible according to everything we understand about climate systems. But it happened at exactly 12,800 years ago, and we have the ice core data to prove it. Ice cores drilled from the Greenland ice sheet provide the most detailed climate record we have of this period. And when scientists analyze the oxygen isotope ratios in these cores, which tell you what the temperature was when that particular layer of ice formed, they see a sharp and dramatic change right at the younger Dryas boundary. Temperatures that had been steadily warming as Earth came out of the last ice age suddenly plummeted. And the transition happened in less than a human lifetime, and possibly in less than a single decade, according to some of the most detailed analyses. The Younger Dryas cold period lasted from 12,800 years ago until 11,600 years ago, so we're talking about over 1,000 years of abnormally cold climate. But what's really shocking about it is how abruptly it both started and ended, because the climate doesn't gradually cool down over centuries the way you'd expect from normal orbital forcing or ocean current changes. Instead, it crashes suddenly and then snaps back to warm conditions just as suddenly, and that pattern strongly suggests an external forcing mechanism rather than internal climate variability. In Greenland, the temperature drop was around 15 degrees Celsius within just a few decades at most, but the effects of this cooling were felt globally. Ice cores from Antarctica show cooling, though less severe than in the northern hemisphere. Lake sediments from Europe show vegetation dying off and being replaced by cold adapted tundra species. Ocean sediment cores show dramatic changes in plankton populations, indicating much colder surface waters. And tree ring data from the few trees that managed to survive shows growth rings are narrowing dramatically, which indicates severe environmental stress. The incredible speed of this climate change is what makes it impossible to explain with conventional mechanisms. Because normal ice ages take thousands of years to develop, as a gradual orbital variations slowly change the amount of sunlight reaching different parts of Earth, ocean currents shift gradually over centuries as salinity and temperature patterns evolve, and ice sheets advance and retreat at literally a glacial pace. But the Younger Dryas doesn't fit any of these patterns because it happens far too quickly to be driven by these slow natural processes, which is exactly why climate scientists struggled for decades to explain it, until the impact hypothesis finally provided a mechanism that actually works. Here's how a comet impact could cause such rapid and severe cooling. When you have multiple large fragments exploding in the atmosphere, the debris and dust get thrown up into the stratosphere, where they stay suspended for months or even years. And this debris blocks incoming sunlight, similar to what happens after major volcanic eruptions, but potentially much more severe depending on the total amount of material. And reduced sunlight means reduced temperatures, which means reduced plant growth, which means reduced food supply for animals and humans. And you get these cascading feedback effects where the initial cooling triggers additional cooling mechanisms like increased ice formation, which reflects even more sunlight back into space. The massive wildfires triggered by the impact would have added enormous amounts of soot and smoke to the atmosphere on top of the impact debris. And scientific studies have shown that soot particles are particularly effective at blocking sunlight because they absorb visible light rather than just reflecting it. So you'd have both dust from the impact and soot from the fires working together to create what would essentially be a nuclear winter scenario lasting for years or even decades. The human impact of this climate catastrophe would have been absolutely devastating. Imagine you're living in what seems like a thriving society with the beginnings of agriculture and some permanent settlements, and suddenly the temperature crashes and crops fail, and game animals either die off or migrate away, and water sources freeze over, and you're facing immediate starvation and exposure to the cold. And the archaeological record shows us exactly this pattern, where sophisticated sites occupied before the Younger Dryas are suddenly abandoned and human populations crash dramatically. In 2018, researchers were using ground-penetrating radar to map the bedrock beneath the Greenland ice sheet when they discovered something that absolutely shouldn't be there. A perfectly circular depression 19 miles wide, hidden under more than a mile of solid ice. And when they analyzed the structure and the disturbed ice layers above it, they realized they were looking at an impact crater that formed during the Younger Dryas period. And suddenly the skeptics who had been saying there's no crater didn't have their main argument anymore. The crater is called Hiawatha Crater, and it's located in northwest Greenland beneath the Hiawatha Glacier, and the structure is remarkably well preserved considering its age because it's been protected under ice since the moment it formed. And when scientists use multiple independent dating methods, including analyzing the disturbed ice layers above the crater and studying the drainage patterns of the glacier itself, all the evidence pointed to an impact occurring between 13,000 and 12,000 years ago, which overlaps perfectly with the start of the Younger Dryas at 12,800 years ago. For years, the biggest argument against the Younger Dryas impact theory was the complete absence of a smoking gun crater. Skeptics would say that if an impact large enough to cause global climate change and mass extinctions actually occurred, then where's the crater? But this argument conveniently ignored several important facts. First, that most of Earth's surface is covered by oceans, where impact craters would be completely hidden and almost impossible to find. Second, that craters can be buried by sediment accumulation or eroded away over thousands of years, especially in geologically active regions. And third, that the impact might have been primarily an airburst explosion, like the Tunguska event in 1908, which released enormous energy but didn't leave a traditional impact crater. The discovery of Hiawatha Crater completely changed the conversation because now we have direct physical evidence of a major cosmic impact occurring in exactly the right location and exactly the right time frame. And an impact over the Greenland ice sheet would explain so many of the Younger Dryas phenomena we've been talking about. The sudden cooling from debris blocking the atmosphere, the massive flooding from instantly melted ice, the particularly concentrated effects in the North Atlantic region, and the disruption of ocean currents that would have extended and amplified the cooling period. What makes this crater particularly significant is its sheer size because a 19-mile-wide impact crater requires an impactor roughly 1 mile in diameter, and an object that size hitting Earth at typical cosmic velocities would release energy equivalent to hundreds of millions of megatons of TNT. And to put that in perspective, the largest nuclear bomb ever tested by humans was about 50 megatons. So we're talking about an explosion that was literally millions of times more powerful than the most destructive weapon humanity has ever created. And that kind of energy release would absolutely be capable of triggering all the climate effects and extinctions we see in the geological and fossil record. The crater structure itself shows features that are consistent with an impact into thick ice rather than solid bedrock. The central peak is significantly lower than what you'd expect for a crater of this size in solid rock. And the rim structure shows evidence of being disrupted and modified by ice movement over thousands of years, both of which make perfect sense if the impactor slammed into and melted its way through a massive ice sheet that was potentially several miles thick. And the instantaneous melting of a significant portion of the Greenland ice sheet would have released absolutely staggering amounts of fresh water into the North Atlantic, which could have severely disrupted the thermohaline circulation that moderates climate throughout the Northern Hemisphere. Some researchers believe that Hiawatha might not be the only impact site from this event, because there's evidence suggesting multiple impact locations, which would make perfect sense if a large comet broke apart as it entered Earth's atmosphere, creating several fragments that hit different areas. And if multiple large fragments struck different parts of the planet, it would explain why the effects were so widespread and global, rather than being concentrated in just one region. The timing of the Hiawatha discovery is still being refined, and there's some debate about whether it dates to exactly 12,800 years ago or might be slightly younger. But even if the crater turns out to be a few hundred years off from the precise start of the Younger Dryas, it's still incredibly significant because it proves beyond any doubt that Earth was being hit by major cosmic objects during this exact time frame. Before the Younger Dryas, we have evidence of sophisticated structures like Göbekli Tepe that required advanced planning and astronomical knowledge and precision, stone carving that takes decades to master. And then, during the 1,000-year cold period, everything stops. These sites are abandoned, and when humans finally come back and start building again, They're working with much cruder tools and simpler structures as if they had to relearn basic skills from scratch. And that pattern of advancement, followed by collapse, followed by slow rebuilding, suggests massive knowledge loss from a catastrophic event that killed most of the population. The archaeological record shows a really dramatic change right at the Younger Dryas boundary, because before this period you have sites showing evidence of permanent or at least semi-permanent settlements, sophisticated stone tools that required significant skill to manufacture, long-distance trade networks that were bringing in materials from hundreds of miles away, and structures that clearly required planning and coordinated labor involving many people working together. But then many of these sites are suddenly abandoned right at the boundary, and when humans eventually return to these areas, centuries later, they're building much simpler structures and using cruder stone tools. Göbekli Tepe in modern-day Turkey is probably the most famous and dramatic example of this pre-Younger Dryas sophistication, because this site has these massive T-shaped limestone pillars that weigh up to 20 tons each and are arranged in carefully planned circular enclosures. And the pillars themselves are carved with incredibly detailed reliefs showing various animals and abstract symbols that clearly had some kind of symbolic or religious meaning. In radiocarbon dating places the construction of the oldest parts of this site at around 11,600 years ago, which is right at the end of the Younger Dryas cold period, but there's evidence suggesting the site was occupied even earlier and that the elaborate construction represents people rebuilding and trying to preserve knowledge from before the catastrophe. The level of organization and technical skill required to quarry and transport and precisely position these massive carved pillars simply doesn't fit with the mainstream narrative of primitive hunter-gatherers who were supposedly just barely surviving and had no surplus time or resources for major construction projects. These were clearly people who had developed sophisticated social structures and accumulated enough food surplus that they could support specialist craftsmen in large coordinated work parties. And then that entire capability seems to vanish during the Younger Dryas cold period and only gradually comes back over the following millennia. Genetic studies of human populations show a severe bottleneck right around the Younger Dryas period, meaning that global human population crashed to perhaps just a few thousand surviving individuals. And when your population gets reduced to numbers that low, you inevitably lose specialists and specialized knowledge, because you lose the people who knew how to work stone with precision, or how to navigate by the stars, or how to preserve food for long periods, or how to organize large groups for construction projects. And the surviving populations would have been focused entirely on immediate day-to-day survival rather than on preserving and passing down complex technical knowledge. So crucial information would have been lost with each generation that died until eventually you're left with only the most basic survival skills. The sites and artifacts that did manage to survive through this period show this knowledge loss pattern really clearly. Before the Younger Dryas, you find sophisticated composite tools made from multiple carefully shaped components. But after the cold period, the tools are much simpler and cruder, as if people were rediscovering or reinventing basic techniques. Before the boundary, you find evidence of long-distance trade in exotic materials like obsidian that had to come from sources hundreds of miles away. But after the catastrophe trade networks collapse and people are using whatever local materials they can find, and this isn't a gradual simplification over time, but rather a sudden break followed by a very slow recovery. What makes this pattern even more interesting is thinking about what specific types of knowledge would survive versus what would be lost in a catastrophic population collapse. Practical survival skills like making fire and basic hunting techniques and simple shelter construction would obviously survive because they're essential for staying alive and they get used every single day. But specialized knowledge like advanced astronomy and sophisticated construction techniques and early forms of writing or symbolic notation would be much more vulnerable to loss because they're not immediately essential for survival and they require dedicated specialists to preserve and transmit to the next generation. The so-called Neolithic Revolution, where humans supposedly suddenly figured out agriculture and started building permanent settlements and developing civilization for the first time around 10,000 years ago, this might not actually represent humans discovering these things for the first time, but rather represents survivors slowly rebuilding population and rediscovering or remembering knowledge that had been lost during the Younger Dryas catastrophe. Your ancestors remembered what happened that day? Every single one of them, no matter where in the world they lived, and they all told essentially the same story about fire falling from the sky and water drowning the world, and almost everyone dying. And we're still telling these stories 12,000 years later because the event was so traumatic and so catastrophic that nobody could ever forget it. This isn't mythology. This is cultural memory of real events preserved through thousands of years of oral tradition. Over 200 different cultures from all around the world have flood stories that are remarkably similar to each other, and mainstream archaeology typically dismisses these as coincidental myths or symbolic religious stories that don't reflect actual historical events. But when you actually take the time to analyze these flood traditions carefully and try to work out the dating and compare the specific details, they all seem to point to the same basic time frame, around 12,000 to 11,000 years ago, and that's not coincidence. That's evidence of cultural memory of a real catastrophe that affected the entire planet and was passed down through countless generations of oral storytelling. The flood stories from different cultures aren't vague or contradictory. They're actually remarkably consistent in their core details. The Sumerian flood myth describes Utnapishtim, who was warned by the god Ea about a coming flood and told to build a boat to survive. The Hebrew story of Noah and the Ark is almost identical in its basic structure. The Greek myth tells of Deucalion, who survived a great flood sent by Zeus. Hindu sacred texts describe Manu, who was warned by a fish avatar of Vishnu about a coming deluge. Chinese legends speak of Gunyu, who had to control catastrophic flooding that threatened to destroy civilization. And Mayan and Aztec codices describe multiple great floods that ended previous ages of humanity and forced the survivors to start over. What all these stories describe matches up perfectly with what you'd expect to see from a Younger Dryas impact scenario. Because if multiple large comet fragments hit the ice sheets covering North America and Northern Europe, the enormous thermal energy released would have instantly melted cubic miles of ice, turning it into water in a matter of hours or days. And all that melt water would have to go somewhere, creating absolutely massive flooding across the continents and raising global sea levels by potentially hundreds of feet, which would have completely inundated all the coastal regions where the majority of human populations were likely concentrated. The geological evidence strongly supports the idea of catastrophic flooding at exactly this time frame, because all across North America you find these features called scablands, which are areas of deeply channeled terrain that show clear evidence of massive water flows far beyond anything that normal rivers could ever produce. The channeled scablands in Washington state are the most dramatic example showing erosion patterns that could only have been created by truly colossal floods, moving billions of gallons of water at incredible speeds. And while mainstream geology typically attributes these features to glacial lake outburst floods, the timing of their formation corresponds exactly with the Younger Dryas period, and the scale of erosion suggests something far more catastrophic than just a dam breaking. Sea level rise at the end of the last ice age wasn't a gradual, steady process. There were distinct pulses where sea levels jumped upward by tens of feet in relatively short time periods, and a Younger Dryas impact that caused rapid melting of major ice sheets would create exactly this kind of sudden dramatic sea level rise. And underwater archaeology has found clear evidence of human settlements and structures that are now located hundreds of feet below current sea level, with walls and roads and building foundations that were obviously constructed above water, but are now completely submerged, proving that coastlines were dramatically different before the flooding, and that coastal populations would have witnessed and experienced this catastrophic inundation firsthand. The specific details in many flood myths include elements that directly correspond to impact effects. Many stories specifically mention that the flood was preceded by fire falling from the sky, which perfectly matches the scenario of burning debris from a comet airburst raining down over vast areas. They describe the water as being so powerful and violent that it carved new valleys and moved mountains, which matches the kind of erosion we see in the geological record. And many of them explicitly state that the flood was followed by a long period of cold and darkness, which is exactly what you'd expect from impact debris blocking the sun and triggering the Younger Dryas cooling period. The Younger Dryas impact happened 12,800 years ago, but comets don't follow schedules or calendars. They come hurtling in from the outer solar system on completely unpredictable orbits, moving at tens of thousands of miles per hour. And right now, there are objects out there that we haven't even discovered yet that could be on a collision course with Earth hitting us tomorrow or next year or next century. And the terrifying truth is that we currently have no reliable way to stop them. So the question really isn't whether this kind of catastrophic impact can happen again. The question is when it will happen and whether we'll be prepared when it does. The torrid meteor stream, which Earth passes through twice every year in June and November, is believed to be debris from a giant comet that broke apart sometime in the relatively recent past. And some researchers think the Younger Dryas impactor might have come from this debris stream, which means we're literally passing through the same field of potential impactors every single year. And while most of the material in the stream is small enough to burn up harmlessly as shooting stars, there could easily be much larger fragments lurking in that orbital path just waiting to intersect with Earth at exactly the wrong moment. NASA and other space agencies do track near-Earth objects, and they've managed to catalog thousands of asteroids that cross Earth's orbit. But their ability to detect comets is far more limited because comets can come from literally any direction, with very little advance warning. Asteroids orbit in relatively predictable paths within the inner solar system that we can map out decades in advance. But comets can appear from the outer reaches of the solar system, giving us only months or even weeks of warning time. And if we only have a few months' notice, there's really nothing our current technology could do to deflect or destroy a large incoming comet. We know from the geological record that impacts on this scale happen with some regularity on geological timescales. Earth has been hit by major objects many times throughout its history and will certainly be hit again many times in the future. It's not a question of if, but simply a matter of when. And right now, despite all our technological advancement, we have no comprehensive planetary defense system that would be capable of protecting us from a large comet arriving from the outer solar system with limited warning time. The Younger Dryas impact isn't just ancient history that we can file away and forget about. It's a stark warning written in the geological record telling us that Earth can be hit by objects large enough to completely reset human civilization. And it happened recently enough that we have abundant physical evidence that we can study and learn from. The platinum anomaly and the nanodiamonds in the Hiawatha crater aren't just interesting scientific curiosities. They're proof of the most catastrophic event to affect humanity in the last 100,000 years. The evidence is undeniable. 12,800 years ago, something from space hit Earth with enough force to end the world as it existed at that moment. And the question we need to be asking ourselves is whether we're doing enough right now to make sure that when the next comet comes, we'll be ready for it. Because the universe doesn't care about our cities or our technology or our 8 billion people. And unless we take the threat seriously and invest in real planetary defense capabilities, we could be looking at another reset, and this time we might not recover.